We're going to look at 4F, working with brackets. So we're going to teach you here how to use the distributive law to write expressions in expanded form. So we are going to have a series of questions that involve a set of brackets, and what we're going to do is we're going to expand the expression, which means that we are going to remove this bracket. So we're going to work with both numbers and pronumerals, typically in the same question. So here is a rule. This rule here is something you should write into your summary books. So if we have an example of a bracket expression with A bracket B plus C, what this A in front of the bracket represents is that it is multiplied by everything that is on the inside of the bracket. So the way we show this expansion is like so here, where we multiply A with B and we also multiply A with C. Okay, so this A is common to both B and C, so we need to perform that multiplication with the B and the C. And then we can write this even more simply by writing the A times B as just AB and A times C as AC, with the plus sign in the middle in this case because it's an addition. Okay, so you may even want to do this as a bit of assistance by just draw an arrow there, put a times sign. Okay, and I could do the same from A to C. Okay, you don't have to do these arrows and the times all the time, but you can use that if you need to, just to help you. So now we're going to do some examples together. We're going to first look at multiplying 6 by k plus 4, which is in the bracket. So if we use our distributive law, we multiply 6 by k, we've got 6 times k, we multiply 6 by 4, which is here. We know we're adding them together. We can write 6 times k in simplest form as 6k, and 6 times 4, we need to simplify that to 24. So that's your final answer there. Question B, we have 2, then multiply that by 3x plus y. Again, we use our distributive law, multiply the 2 by the 3x, and then we multiply the 2 by y. Again, plus sign in the middle. Simplify 2 times 3x. Okay, 2 times 3 is 6. This x, okay, needs to also be written next to the 6. 2 times y, get rid of the times sign in the middle, and we write it as 2y. The last one, we have 4 times a, and then 4 times negative 5. Okay, so we're going to just pay close attention to this last value here. So we're looking at simplifying this to 4a, and then a positive and a negative number, always a negative, 4 5s to give us 20. All right, now these two questions here look a little bit more complex. Okay, some more pronumerals involved. Okay, so that's going to add some more complexity to your question. Looking at question A, we have 7p multiplied by 3q plus 4e. Again, using our distributive law, 7p times 3q, and then I have to add that to 7p times 4e. So let's look at the first part. Okay, let's deal with that. 7 times 3 is 21. P times Q is PQ. Okay, I'll just write them in alphabetical order. The second part is 7 times 4, 28. And then P times E we can write it in alphabetical as EP. That's all. Okay, can't do any more with that. They're not like terms, so you leave it as is. Question B, I've got the same letter. Okay, so this is going to involve a power in the end, which we can see here. So if we look at first expanding, 2m times 5m plus, now it's a plus because this 2m is positive. So it's a plus 2m times negative 4. All right, and they put that in the bracket just to make it more clear that it's a negative number. Then we look at simplifying. 2 times 5 is 10. M times m is m squared. Positive times a negative is a negative. So this is why now we have this negative in our final solution. 2 times 4 is 8. And just one m here, we put it next to the 8. Second part to exercise 4F. Okay, questions are going to get even more complex. So now we're looking at 3 terms in a set of brackets. Same process as what we were doing before. Okay, so this 4 still needs to get multiplied by every single term in here. So we do that. 4 times 2p plus 4 times the k, it's in the middle, and plus 4 times a negative 3m. Again, I've put that in the brackets just to show that it's negative. Take each section separately. Okay, we've got 3 parts to this answer, as you can see in the answer here. 4 times 2 is 8. Just a p on its own next to the 8. 4 times k, get rid of the times sign, it's 4k. 4 times negative 3 is negative 12. This m on its own, put it next to the 12. No more can do with that. Final solution. Question B. Again, negative 3 times by 4xy plus negative 3 times 7a plus negative 3 times negative 1. Okay, few more negatives now popping up here. But again, just take each third, I'll call it, separately. Negative 3 times 4 is negative 12. xy, okay, it doesn't share anything in common with the negative 3. We write it next to the 12. Negative 3 times 7 is a negative 21. There's only one letter A here in this part, next to the 21. Negative 3 times negative 1, 2 negatives change to a positive, 3 ones are 3. Last part, we're going to look at an application question. Okay, so we're going to look at a rectangle shape, and this rectangle is actually split into 2 rectangles. Okay, so we want to demonstrate that this expression here, 7 times 4m plus 5, is equal to 28m plus 35 by finding the appropriate areas in the diagram. So we're going to find the areas of these individual rectangles, and we're also going to find the area of the whole rectangle itself, and then work our way to finding that this is a true statement. So the first thing we're going to do is look at the large rectangle. So this whole thing all together. Now, area of a rectangle, for those of you that perhaps have forgotten, is length times width. Okay, it doesn't matter which side is length and width. Okay, you're multiplying, so it doesn't matter even if you switch positions, you'll still get the same result. So here they've shown that 4m plus 5, which is, okay, this side here, let's just call it the length. Okay, so this length multiplied by the width, which is 7. Okay, we can write it out like this and then simplify it, which is exactly what they've stated here. So that's already the big rectangle. Now we move on and we're going to find the area of this rectangle here on the left, the small one. It shows me here that width is 4m. So this 4m needs to get multiplied here by the length, which is 7. So I write it as 7 times 4m. Simplify that, 7 4s are 28, and the m next to it. This rectangle here on the right, this here is a width of 5. We know that length of 7, 7 5s to give 35. So we can see these two numbers, or these two terms, appear here. So now if we're going to prove that that is a true statement, the area of this large rectangle, okay, which we know is this one here, it must be these two smaller rectangles added together. Okay, so I've just written in words, area of the small rectangle on the left plus the area of the small rectangle on the right. They're the two individual answers, the small rectangle on the left and the small rectangle on the right. They've shown that by putting a plus sign in between them. Hence, these two together is equivalent to multiplying the two lengths on the outside of the big rectangle. Okay, take these step by step. Again, as I've said to you in other PowerPoints, don't rush these questions. Okay, think about the words. Follow my step by step process. Okay, if you have to rewind, watch it again, do so. Hopefully this was helpful.